Hey all, welcome back for some more drawing. Okay, so just looking here at the 2018 higher level question C3 on surface geometry. Obviously I've gone and set this one up, but I'm going to talk through what would have caused the problem initially setting it up. So you're told the object is a terrarium, which is a glass container. So basically, just knowing that these are glass surfaces kind of lets you understand why some of the lines aren't hidden detail. Okay, even though I put a hidden detail line in here, technically shouldn't. So you can see through the glass in places. There are sections where there's no glass for the planting of plants. So there's no glass in that section there, which means you can see into this. And on this one, I've written this is open here, so you can see into this. Okay. So from initial setup, I started with the plan. Okay, scale of 1 to 3, sides of this square are 210, so divided by 370. So each side is a 70. It's set up at an angle of 15 degrees. So I picked a starting point, drew my horizontal, put the protractor on and set up 15 degrees, drew that line out there, measured out 70, went perpendicular, 70, 70, and the top on the square. For the inside square, okay, the inside square is sides of 105 divided by 3 is 35. So the sides of this square are 35 millimeters. Okay, again, I see each corner of the square sits on the diagonals of the larger square. So I drew on my diagonals. Now, the next part of this, 35 millimeters from, let's say, point 1 as far as point 2, or point 1 as far as that point, whichever way you want to do this, right? So if you were stuck, you could go and you know yourself that if you put a center line there, okay, parallel to the edges, through the center point I've called point O, technically you have half of the 35 from that point out to there and half of the 35 from that point out to there. Okay, so half of 35 happens to be 17.5. You could, if you were really stuck, measure 17.5 each side of the center and bring it back to give you those points. From a drawing or DCG or even a tech graph point of view, that wouldn't really be the right way of doing this. Okay, so you would look and kind of go, what you need to be able to notice is that if this is 35 from here to here, okay, so 35 from here to here, obviously between that space and that space is also 35 left over to make up the full length of 70. Okay, if I'm dividing that in two to give me my 17.5 and 17.5, well then the other 35 is divided the same way, so there would be 17.5 left there and 17.5 there. So essentially I'm dividing that 70 into 4 spaces of 17.5. Again, I'm not going to do that because trying to measure 0.5 on the set square isn't really accurate. So one way of doing this, so this is the way I've done this, is I decided, right, so I need to basically split that side into 4 equal spaces. I could have done it for this side or that side or that side. I just chose this one because it was at the bottom and there was the open space there. So I drew on my horizontal line, I measured out 4 equal spaces. I think I went with 20, 20, 20 and 20. Fourth point, join back to the end of the line, and then parallel to that from 3, 2 and 1. Okay, so back to first year tech graph, dividing a line into an equal number of spaces. Okay, so parallel from that fourth point. I took this point and then brought them back parallel to the 2 edges of the square, which gave me my point 1 and 2. And when I checked that, that is 35 millimeters between those 2 points. Okay, which is what it's supposed to be. That lets me draw in the rest of the square. Okay. Once the square is drawn in, I can then take each of my corners up from my front elevation. So starting with this bottom section, okay, height of 20, 40 and 40. I'm getting that from my 60, 120, 120 divided by 3. Brought my heights across. The very bottom shape, the square, is sitting on the ground. So I've taken that point up as far as there, that point up as far as there, and the back edge as far as there, the hidden detail edge back as far as there. So there's the base of that object. Okay. Surface, the bottom surface, which is going to be surface A, runs from here up as far as this point. So I've taken that point up there. It's at a height of 20. That joins back to the base. I've taken this corner here up. That's at a height of 20. That joins back to this point, which is there. On this side, I've taken that point up, height of 20, joins back as far as that point, and on the back of the object, that corner, which is at a height of 20, joins as far as that point, which is on the ground. Okay, now again, I initially drew this in as a hidden detail line. Really, it isn't hidden detail because all of these surfaces are glass, so you will see the edge lightly. I suppose in the question, this is why these edges are drawn in lightly, because you can still see the edge through the glass. But I just left it. I think it's easier to visualize it if I leave it in as hidden detail. Okay, so surface A is sloped that way. Surface B is sloped out this way. In the plan, surface A is that surface right there. Okay, it's underneath that purple surface, or whatever color you want to call that. So that triangular surface there, surface A is underneath it. It's that surface there. Surface B, there it is in front elevation. In the plan, surface B is sitting there. Okay, I can see surface B because this section is left open at the front. So this triangular section is not there on, or sorry, part of the triangular section is not there. So you can see into surface B. Okay. So the first part of the question, even without drawing on the top part of this, asked to draw the plan elevation as terrarium and determine the dihedral angle between surfaces A and B. So even without drawing that, at this stage you could do the dihedral angle. Okay. Line of intersection, there as far as there. Okay. So if I wanted to call that line of intersection, I've already used 1, 2 for this next bit, for another bit of the question. So let's say that's 3 and that's 4. Okay, so my line of intersection is 3 as far as that point there, which is 4. Okay, so that is the line of intersection. Okay, so apart from anything else, I know straight away I'm going to look perpendicular to the line of intersection. The two the two surfaces A and B, I could leave them as the size they are. I would probably change them going from the highest point into the lowest point, the lowest point up to the highest point. I suppose the common point 4. I could draw a line from here up as far as there, and a line from there out as far as there, just to create two triangular surfaces. Okay, and then just work with my dihedral angle. Again, if you're stuck on dihedral angles, go back and find my video I shared on the dihedral angle. Okay. Top of the object, I've called it point O. I've brought that straight up here. Okay, height of 80. Join back down to each one of, as it is in the front, as it is in the plan. Join the same in the front elevation down to each one of the corners. Okay, I can see this is a heavy line because this front section here is open. Okay, so as I look in this direction, I see that as a heavy line from there to there. It's a light line running up along there because it's behind that glass surface, that little section C, which I've shaded in the plan elevation. Okay, so ignoring this part for the moment. Okay, if I was to look at part B of the question, it says develop the surface C. Okay, the minute I see develop written, okay, develop is basically true shape. Okay, so if it says develop the surface C, it's the same thing as saying find the true shape of surface C. Okay, here's my surface C, here's my surface C. Okay, the easiest thing to do is to take that surface as, I always say, take surface C, which is sitting like that, and fold it down onto the ground. All right, so if I look at the front elevation, the line 1, 2 is a horizontal line. So I know that in the plan, the line 1, 2 is a true length line. Okay, because the line is a true length line, I can use that as my hinge edge to rotate that surface out this way. Okay, there's a few different ways of doing this. Basically, we need the true length of the line from O down as far as the line 1, 2, a perpendicular distance. So basically O down as far as that point if I was to bring it up here. Okay, so we could take that line and we could rotate it onto horizontal and rotate it up here and get its true length and step it out this way. I always think it's easier to take an edge view of the surface. So I'm going to put that up there for a minute. So I always think the easiest thing to do, take an edge view. So looking along the true length line, Bring this out here perpendicular. There's my XY. I also need to bring out point O. Okay, so again, I am looking in that direction. Okay, look that direction along the true length line. The true length line is going to become a point for you. So remember, I'm in this view, last view, second last view. So I'm really taking my heights up here. I don't need all that distance, that's 60 millimeters there. So what I'm going to do is I'm going to put in a datum XY at this height. So there is my datum XY. Okay, so because my datum XY is on the line 1, 2, my height for 1, 2 is 0. So coming out along from 1, 2, my height for 1, 2 is 0. So, and 2 is first, so 2, 1 are going to sit at that point. My height for 0 is 40 millimeters. So my height for 0 over here, 40, there's point 0. Okay, so when I join that 0 back to the point view of 2, 1, there is an edge view of surface C. Okay, so this is an edge of surface C. Okay. Now that I've got an edge view, I'm going to take that and rotate it onto the ground. We said we're going to rotate it about the point 1, 2. So at the point of the compass there, I'm going to rotate this onto the ground. When I say the ground, I mean the horizontal plane. I need to extend my horizontal plane. So remember, in this view, that X1, Y1 line represents an edge view of the horizontal plane. Okay, so edge view of the horizontal plane or the ground. I've rotated this onto the ground. Okay, so point 0 has now ended up here. Sorry, this is a little bit confusing with the overlapping on the text. Joins back to 2, 1. 2, 1 hasn't moved because that's the hinge edge. Okay, so once I've rotated that, I can now take this back parallel to the line coming out from 1, 2. So that goes back there. It has moved out perpendicular to the hinge edge, our usual rule. And I'm going to join it back. So 0 is actually out here now. Sorry, I just realized that it's a little bit confusing, the fact it ended up on top of the text. But there's that triangular surface from there as far as there. Okay, so my true shape for surface C is that surface there. Okay, and the usual thing follows for all these true shapes or developments is that the surface will always appear bigger than it did in the other views because we're now looking at it at 90 degrees. So there's my surface. Okay, folded along the line 1, 2, the true length line, down flat, folded down flat, brought back here, brought out perpendicular to the hinge. Okay, that's how you find the development or the true shape of surface C. Okay. I might leave that video at that and I will do a separate video with the construction of this surface over here. Okay, thank you.